Hey there, we're going to look at 4.2 today on rate of change. And so you're going to see that the objective for this is that you'll be able to find the rate of change of an applied problem. Still working in FIF 7, talking and leading towards the graphs of these. And again, we're going to be in linear functions in this chapter. Just a reminder, if you're having issues with this, go to the Zoom study help at 11:30, between 11:30 and 12:30, any day this week, so that you can get the help that you need. And so the first example we're going to look at here, a student weighed 105 pounds in the ninth grade and weighs 170 pounds their senior year. What is the rate of change in weight? Well, remember we talked last week about this slope formula, right? M is equal to y2 minus y1 over x2 minus x1. Another way we talked about the formula is the change in y over the change in x. We use this notation, the delta y over delta x, and that delta does mean change of or change in. And two other words that we use to kind of remind us of which one goes where: rise over run. And so using this information, we're going to take the information we're given and manipulate it to what the rate of change would be. And so m is equal to what? Well, I need some order pairs before I can plug into this, right? And so the first order pair I see is that there's 105 pounds when in the ninth grade. And so 9 relates to the weight of 105. And then same thing with the senior year. The 12 relates to the 170. And so we're going to do 170 minus 105 divided by 12 minus 9. 170 minus 105 is going to give us 65. 12 minus 9 is 3. And so this is 22 and 2/3. Right? Again, a pretty good significant rate of change of the weight. Now, does that mean that every year she gained 22 and 2/3 pounds? 22.6 repeating pounds per year, right? Because again, we're looking at a weight from ninth grade and a weight from senior year. And so that is the average rate of change of this person's weight. Again, it's not a hard problem to look at. It's just a matter of pulling out the two order pairs you're going to have and then labeling x1, y1 and x2, y2. One more example here. Again, like I said, this is not a long section. Just a couple of examples here to look at as we continue in rate of change. The lessons later this week will be a little bit longer than this one, but this one's going to end up being short. Bicyclist is on a ride. After an hour, she rode 17 miles. After 6 hours, she rode 58 miles. What's the average rate of change? So pause the video here, take a second to try this one out, and then let's check on the work. Alright, so hopefully you paused the video, and so let's write these order pairs first, because that's sometimes the best thing to do to know what we're going to be dealing with. Because after an hour, how many hours? Well, that's 1 hour, right? So 1 hour. She rode what? 17 miles. That's a pretty decent clip. After 6 hours, she rode 58 miles. And so again, we're going to plug into our slope formula, right? M is equal to the 58 minus the 17 and the 6 minus the 1. And so 58 minus 17 is going to give us 41, and 6 minus 1 is 5. This will not reduce, but we can convert this to 8.2. And remember, that is 8.2 what? Miles per hour. And so as we look at this example, again, pull out your information. There's your first order pair. There's your second order pair. Plug them into the formula correctly. That's it for this section. Really short day on our e-learning. You'll see at the assignment, which I'll give you a little sneak peek here, does have what you need to be practicing on this, and a couple problems just to think about on given certain dependent and independent variables and what they're trending towards. Think about the statements that they'll give. But that's it for today. If you have any questions, again, use the Zoom session at 11:30 or email me and I'll get your questions answered. Y'all have a great day, and I'll see y'all tomorrow. And before I forget, the word of the day, remember this is a part of what you're going to need to do your attendance form every day. But the word of the day is rate of change. So again, the word of the day is rate of change, and y'all have a great day.